This is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through all the solutions to the week 11 homework sheet. So this is good revision for your test on hyperbole and polynomials. So the first 5 questions all refer to this equation here, y equals 1 over x plus 2 minus 1. Hopefully you recognize this and know that if I were to graph it, it would be a hyperbola. So we're going to answer some questions about this. So the first question asks us to find the asymptotes if I were to graph the equation in black. So the general equation for a hyperbola is y equals something over x minus h plus k. So h and k tell you the asymptotes. This one tells you the vertical, and this tells you the horizontal. So starting with the vertical, we can't have that x is equal to h in this part of the equation, because if x was equal to h, you'd be dividing by 0. So for that reason, the vertical asymptote is always x equals h. So in our equation here, in the original equation, y equals 1 over x plus 2 minus 1, the vertical asymptote would be x equals minus 2. And again, that's because if x was minus 2, this would equal 0. You'd have 1 divided by 0, which you can't do. Now, when we have equations like this, we're really sort of assuming a doesn't equal 0. And you can see up here, of course, a doesn't equal 0. Otherwise, it wouldn't be a hyperbola. So if a doesn't equal 0, the whole fraction can't equal 0. So if I look at this fraction here, 1 over x plus 2, I can't take 1 and divide by any number to get 0. There is no number x such that 1 divided by x is equal to 0. What that means is this whole fraction can't equal 0. Similarly, when we're looking at the general form, this whole fraction cannot equal 0 if a is not equal 0. So what that means is that y can't be equal to 0 plus k. So that's why the horizontal asymptote is always y equals k. That means y can never equal k because this cannot equal 0. So similarly in our example up here, this fraction cannot equal 0, so y cannot be 0 minus 1. Y is not allowed to equal minus 1. So the horizontal asymptote is y equals minus 1. So the second question asks, for this equation up here, what happens to the y value as x approaches infinity? So this notation, x approaches infinity, is a shorthand way of saying x gets larger and larger. So what happens to the y value of this equation as x gets larger and larger? So if you're really stuck and you have no idea, you can substitute x here for a really large number like 1,000,000. Just don't make it too large, otherwise your calculator will get an overflow error. And if you put that on your calculator, that will give you an indication of what the answer is. But what happens in this equation, as x gets larger and larger, x plus 2 gets larger and larger. So this on the bottom, the denominator will get really large. Now, when you take 1 and you divide by a really large number, you get something very close to 0. So as x approaches infinity, as x gets larger and larger, what will happen to y is this part of y, this will get closer and closer to 0, but it'll never actually equal 0. So y will get closer and closer to 0 minus 1, which is minus 1. In other words, y is actually getting closer and closer to its asymptote. So y will get closer and closer to, but never actually equal minus 1 as x gets larger. So the next question asks us to say what happens to y as x approaches minus 2 from the right-hand side, from the positive side, is what this means. What that's saying is, if x is a number that is just slightly more than -2, what will the y value be? So once again, if you were really stuck here, you could substitute x for a number that's just slightly more than -2, like minus 1.999 or whatever, and see what happens to y. But we're going to do it a little more analytically. So if x is just a little more than -2 here, like minus 1.99, this will be a very small positive number, because if x is more than minus 2, x plus 2 will be greater than 0, i.e. positive. If I substituted x for minus 1.99, this would be a very small positive number. So what happens is, when you have 1 divided by a very small positive number, you get a very large positive number. Like 1 divided by 0.001 is 1,000. So this fraction will get larger and larger, and it will be positive. So this will be a really large positive number, so the minus 1 won't really matter. So what is happening as x approaches minus 2 from the positive side, y is just getting larger and larger, more and more positive, and so we just write it like this: y approaches infinity. So question for us is to find the intercepts of this graph here. So of course, not all hyperbolae have intercepts. We've seen graphs like y equals 1 over x or y equals 2 over x. They don't have an x-intercept, they don't have a y-intercept. Now it turns out that this graph here will actually have both an x and y-intercept. So it doesn't even matter if you can't tell off the top of your head whether it'll have intercepts. Just try and do what we've always done and see what happens. So what we've always done to find the y-intercept is let x equal 0. So if I let x equal 0 in this equation here, I get y equals 1 over 0 plus 2 minus 1, which is minus a half. So there's no reason in the world that x can't equal 0 here. In fact, the only number x can't equal is minus 2. So we have that the y-intercept is minus 1/2. Now we're going to find the x-intercept by letting y equal 0. So I can let y equal 0. The only value y can't equal is minus 1. So then I take my equation and I just substitute y for 0, I get 0 equals 1 over x plus 2 minus 1. All I need to do is solve that. So I'll add 1 to both sides, and then I'm going to multiply each side by the denominator of this fraction. I'm going to multiply each side by x plus 2. So I get x plus 2 is equal to 1. Of course, now I just subtract 2 from both sides to get x is equal to minus 1. So the y-intercept is minus a half, the x-intercept is minus 1. All right, now I'm going to do question 5, so I'm going to rub off the working out for questions 1 to 4. So please pause and copy down if you need. So question 5 asks, if I were to graph this, would this be in the top right, bottom left, or top left, bottom right? So what am I talking about here? Well, here again is the general form of a hyperbola. So I'm just going to quickly graph like a general hyperbola. So starting off with my axis, I know that every hyperbola always has one vertical asymptote, so I'm going to put it here, and one horizontal asymptote that I'll put there. Okay, so it really doesn't matter if the asymptotes are above the x-axis, to the left, to the right. The argument I'm going to give here will be exactly the same. So whether it's top left, bottom right, or top right, bottom left is totally determined by this a value, what's on top, whether it's positive or negative. So we have our two asymptotes here. Now, if a is positive, the graph looks like this. So what we can see here is the two asymptotes, if you like, divide our graph into 4 quadrants. If a, the number on top of the fraction here, is positive, then the hyperbola exists in the top right and the bottom left. And it's the opposite if a is negative. So if A is positive, you get the situation in blue. If A is negative, you get the situation in yellow. So what that means for our original graph up here, because A, the number on top of the fraction, is 1, which is positive, it means that when I graph it, it'll look like this blue graph here. So the answer to question 5, is it top right, bottom left, or top left, bottom right? Because A is positive, it's top right, bottom left. So that's questions 1 to 5 done, which referred to the same equation up here. So these are the sorts of things, question 1 to 5, they're the things you need to go through when you're graphing it. But now what we're going to do, instead of graphing this one, we're going to graph a different one without any scaffolding, anyone taking you through the steps. So again, please pause and copy this down if you need. So question 6 asks us to graph y equals -1 over x minus 2. So I just want you to be aware that is exactly the same as writing it like this. So in this case, a, the number on top of the fraction is negative. So when we're graphing a hyperbola, and hopefully we know that this is a hyperbola from the equation, let's always start off by finding the asymptotes. So there's always a vertical one and a horizontal one, and I showed you how to find them before. So the vertical asymptote is going to be x equals 2. Of course, I can't have x equals 2 here, because then it'll be -1 divide 0, and you can't divide by 0. Now there's no k value, no constant sort of away from the fraction, so all that means is the horizontal asymptote is going to be y equals 0. As I said before, if we have a non-zero numerator, so the number on top of the fraction is not 0, the whole fraction can't be 0. There's no number you can divide -1 by to get 0. So the value of this fraction can't equal 0, therefore y can't equal 0, and that's the asymptote. So let's now draw these asymptotes. So now we've graphed the asymptotes. Let's have a think about what we were talking about in question 5. Is this going to be top right, bottom left, or top left, bottom right? So for this equation, we have that a is -1. So because a is less than 0, a is negative, this will exist in the top left, bottom right. So it'll exist over here in this quadrant and this quadrant here as well, just like I explained in question 5. So we know that it's sort of going to look like it's going to be over here and over here. We don't know exactly how far it's going to be. So what we might do is just substitute a couple of values for x in order to understand the shape a little better. So I'm going to find the points where x equals 1 and x equals 3. I just substitute them into my original equation up here. So if x is equal to 3, y is -1 over 3 minus 2. And of course, that just equals -1. So now if I substitute x is equal to 1, I get y is equal to -1 over -1, which gives me +1. So I now have 2 more points I can plot. So now I plotted the points 3, -1, and 1, 1. I know the shape of the hyperbola. I know it's going to get closer and closer to the asymptotes. So my graph will look like this. And so after I've drawn that in, I am done. Let's now move on to question 7. So in question 7, we're given a graph that looks like this, and we're asked to find its equation. So I know that it's a hyperbola, so it's going to be of the form y equals something over x minus h plus k. So what I'm going to do first is look at the asymptotes, because the asymptotes tell me the h and the k value. The vertical asymptote here is x equals 3. The horizontal is y equals 2, and I apologize, they were much clearer on the question sheet. So we, from this, can get the value of h and k. So h is just 3, and k is 2. So I know that this graph is going to have an equation of the form a over x minus h, because the asymptote that's vertical is 3, plus 2, because the vertical asymptote was y equals 2. So in essence, there are 3 variables I need to find, a, h, and k. So I found h and I found k from the asymptotes. Now I need to find a. So I'm going to do this just like I did when we were doing quadratics. I'm going to substitute in the value of a point to find what a is. So there's a couple of points that are clear. We just need to pick any point that's clear. So on the graph on your sheet, the point 4, 4 is clear. This one here, also another point you could use is 2, 0. So I'm going to substitute x equals 4, y equals 4 into this equation so I can rearrange and find the value of a. So substituting in the point 4, 4, I get this really easy equation to solve. It's easy because 4 minus 3 is just 1. So I am just left with 4 equals a over 1, which is just a plus 2, and therefore a is equal to 2. Note, I would have got the same answer had I used this point here. So note, I got a is positive 2, so I know I've done something right. I expect that a is positive. It must be positive because the hyperbola is in the top right and bottom left. So now I've found the values of a, h, and k, I have my equation. The equation is just y is equal to a, which I figured out was 2, over x minus h plus k. So if I were to graph this equation here, I'd end up with a graph that looks like this. All right, now we move on to question 8. So question 8 asks us to give the equation of a hyperbola that passes through the origin. So you would know by now some hyperbola go through the origin and some don't. So whatever the equation is, it must be of the form y equals a over x minus h plus k, because all hyperbola have that form. So all I need to do is find a value for a, value for h, and a value for k. I'm finding 3 things. Doesn't really matter the order in which I find them. I just need to find 3 values for a, h, and k so that when y equals 0, x is equal to 0. So I'm just going to choose to find h and k first and then find a. But it wouldn't matter if you chose a value for a first. So remember that h and k give you information about the asymptotes. So h is the value that x cannot equal, k is the value that y cannot equal. So if I want this hyperbola to go through the origin, I want x to be able to be equal to 0. So that must mean that h is not equal to 0. Similarly, if I want it to go through the origin, I need y to be able to be 0, which implies that k cannot equal to 0. So I can choose any values for h and k as long as neither of them is 0. I can choose those values and then substitute to find the value of a, just like I did in the previous question. So let's let h and k both be 2. Could have picked other values, but I'll just go with h equals 2, k equals 2. So then my equation becomes y equals a over x minus h plus k. So this is exactly like what I did in finding the equation in the previous question. Started with the general form, found values of h and k, substituted them in. So my next step was to write the new equation, and now I'm going to find the value of a. I know that this passes through the origin. To find a, I'm going to substitute y for 0 and x for 0. That will leave me with one equation with one variable, which will be easy to solve. So I have y is equal to a over x, which is 0 minus 2, plus 2. So what I can do is subtract 2 from both sides, and then times each side by negative 2. And I get the value a equals 4. So now I chose values for h and k, and I found the value of a. So my equation, just like last time, is going to be y equals a over x minus h plus k. So note, there are infinitely many solutions to this question. There'd be a different value for a if I chose different values for h and k. So basically, for every value of h and k, every set of values I choose for these, there will be a different a value. And that's why there are infinitely many solutions. All you need to do to check yours is check when y equals 0, does x equal 0? Equivalently, you can check when x equals 0, does y equal 0? So for mine, I will check doing exactly that. So if x equals 0, I get y equals 4 over 0 minus 2 plus 2. If you really want, you can put that in your calculator. You do get y equals 0. So when x equals 0, y equals 0, therefore this hyperbola passes through the origin. All right, now let's do the remainder of the questions, which are on polynomials. So remember, a polynomial is an expression with, for our cases, one variable, x, where all the powers of x are non-negative integers. So x can only have powers of 0, 1, 2, 3, 4, and so on. So the first one definitely satisfies that. Power of x is 4, a positive whole number. So this is a polynomial. So B is not a polynomial because the x is on the bottom of a fraction. That always means it's not a polynomial because it means that the powers are negative. This is x squared plus 1 to the power of negative 1. So negative powers, definitely not a polynomial. Now in C, x to the power of 5 minus x. This part here is a polynomial, but the root x makes it not a polynomial. Square root of x is x to the power of a half. The power is not an integer, not a whole number, so therefore square root of x is not a polynomial, so therefore the whole thing is not a polynomial just because of the square root of x term. And D, I forgot to put the fx notation, but it's still a polynomial. So it has powers of x, 3, 1, and then this constant term, 1, is just the same as 1 times x to the power of 0, and that's fine. You can have constant terms. So A and D are polynomials, B and C are not. Let's now do question 10. So in question 10, we're given a polynomial. Here it's a polynomial because x only takes non-negative integer powers. We're asked to find, if that's fx, what's the value of f of minus 2? So all that means is take your polynomial and replace x with minus 2. So I've written the polynomial again, so I'm going to replace x with minus 2. Everywhere I see an x, I write a minus 2. Remember, whenever you're substituting a negative, always use brackets. So if you've put the brackets in correctly, you can just put this on your calculator. I'm going to do it by hand. So negative 2 to the power of 5 is negative 32. So negative 2 to the power of 3, that's negative 8. So we have negative 2 times negative 8 is positive 16, minus 2 plus 9, and that just gives me minus 9. Then I'm done. Let's go now and do question 11. So in question 11, we're given a different polynomial, fx equals x squared plus 4, and we're asked to find what f of x plus h is equal to. So this is a polynomial because the powers of x are all non-negative integers. Power here is 2. 4, same as 4x to the power of 0, power 0. So what I do is I just take my expression, and what I'm going to do is replace x with x plus h. So I rub out x, and I replace it with x plus h. So to expand this, well, this is just a binomial expansion you've done many times. It's just x squared plus 2 times the product of the two terms, plus square the second, plus 4. I can't simplify this any further because there are no like terms. So I'm done. Let's move on now to question 12. So in question 12, I'm given two polynomials, f and g, and I'm asked to add them together. So when you're adding together two polynomials, the result is another polynomial, and all you do is add together the like terms. So between f and g, the only like terms are the x's. The only like terms, this one here, minus x and 5x. All the other terms are not like terms, so they stay as they are. So we'll just get x cubed, stay as it is, x squared will stay as it is. Now negative x plus 5x gives me plus 4x, and then the 6 stays as it is. So as I said, the result I get is a polynomial. All right, let's go on to question 13. So in question 13, I have the same two polynomials f and g, but I'm asked to find what is fx times gx. This dot actually means times. We're just not writing an x because it might get confusing with the x's everywhere. So I need to use brackets here. So I take my f polynomial and I'm going to multiply it by g. So the idea here when you're expanding brackets is you need to multiply everything in the first bracket by everything in the second bracket. So I need to multiply x cubed from the first bracket by everything in the second bracket. I also need to multiply negative x from the first bracket. I need to multiply it by everything in the second bracket. So now I just expand these using the distributive law. So x to the power of 3 times x squared is x to the power of 5, and so on. And now I look for like terms. So here only these two are like terms, everything else stays as it is. And so I'm done. Once again, when we multiply together two polynomials, the result is another polynomial. All right, let's now go on to question 14. So here we have two more polynomials, px and qx, and we're asked to find this. So this is p of q of x. So q of x is x squared. So we're just being asked to find p of x squared. So what does that mean? It means I take my polynomial px, which is this here, and everywhere I see x, I'm going to rub it out and instead write x squared. And I'm just going to put it in brackets for simplicity. And similarly here, I'm going to get rid of x and replace it with x squared. That's what p of x squared means. So using index laws, I get x to the power of 8 plus x to the power of 4 plus 1. So what about if I went the other way? If I went q of p of x? Well, what that would be is q of x4 plus x squared plus 1. Because that's what p of x is. This is q of p of x, which is just that there. So q, what it does to an expression is just square it. So q of this expression just squares this expression. So this is q of p of x. And the question asks us, is this the same as this? Well, we know from binomial expansions that a plus b all squared, you can't just square the first and square the second because there's actually a middle term. It works for 3 terms inside the brackets too. If I wanted to expand this, you've got to use FOIL, you've got to use expansions. You can't just square the first, square the second, and square the third. So because of this rule here, I know they won't be equal. So note x to the power of 8 is just x to the power of 4 squared. This is equal to this squared. And of course, this is equal to this squared. That's how I know they won't be equal. If you want to double check and you're still not convinced, you can expand this here. So I've just done it for you on the screen. If I expand this, I get this. If you want more information on how that works, please come and let me know. I'm just underlining why this does not equal this. So the second part of question 14 that asks, is this equal to this? The answer is no. All right, let's go on to question 15. Question 15 asks us to give 2 examples of a monic polynomial of degree 4 that has 3 terms in a constant term of 3. So degree 4 means that the highest power of x is 4, so we'll write that there. So monic means that the leading coefficient is 1. So this will be the leading term here because it's the highest power of x, so its coefficient must be 1 for the polynomial to be monic. It's okay if you don't write the 1. So we're also told that it has 3 terms. So that means it's going to have 2 more terms. So the constant term is 3, so that term will be 3. So now we just have to figure out what we can put in there. So because it's a polynomial, what is going to have to go in that box is a term that has x, x squared, or x cubed. We can't have anything with a higher power of x because then it wouldn't be degree 4. So then what we're going to do is fill in this box. There are heaps of things you can put in there. So you could put in x squared. That is one example. You could write x4 minus x cubed plus 3. That satisfies all the above as well. Perhaps you'd go x4 minus 10x plus 3. All of these are examples that satisfy the above. Again, they're monic because the leading coefficient in all cases is 1. They're degree 4 because the highest power of x in each case is 4. They all have a constant term of 3. And they all have 3 terms. So the x to the power of 4 is 1 term, 3 is another term, and then the third terms are what changes. All right, let's do the final question, question 16. So our final question gives us three polynomials. Fx is a polynomial, so too is gx, and then hx is a polynomial that's just this one minus this one. So notice in f, its leading coefficient is a. We want to find what must be the value of a so that the leading coefficient of this one here is -2. So since h is just this polynomial minus this one, let's actually go and write out h. So this is what h is in terms of f and g. So note that we have to put f in brackets because we're minusing the whole thing. So let's expand the brackets. So all this stuff over here will stay the same. So to expand the brackets, you simply change the sign of everything in the brackets. Now there are some like terms here, minus 2x squared and minus ax squared. So we can write that conveniently as minus 2 minus a of x squared minus 2x minus 1. I'm just writing the terms in descending order of power of x. So, for hx, its leading coefficient, you'd think would be this one here, minus 2 minus a. That's the coefficient of x squared. So, of course, if I want this coefficient to be minus 2, I could have minus 2 minus a is equal to minus 2. A is 0. Right? If a was 0, then the coefficient of x squared would be minus 2. So there's another possibility. However, the other possibility is that the leading term is this one here. So that would mean the coefficient of x squared would be 0. So I can also have minus 2 minus a is equal to 0. And that means a is equal to minus 2. So either of these works. If a was 0 or a was minus 2, when you subtract this polynomial from this one, the leading coefficient would be minus 2. In this case, minus 2 would be the coefficient of x squared. In this case, there would be no x squared term, because its coefficient would be 0. There'd be no x squared term, so the minus 2 would be the coefficient of x, and that would be the leading term. All right, thank you so much for watching. I hope this has helped. This has been the luckiest maths teacher in the world. Have a great day.